My name is Varun Dutt, and I'll be telling you about Large Applications Practicum. I'm a faculty of the School of Computing and Electrical Engineering at the Indian Institute of Technology, Mandi. In this lecture, we are going to build upon our learnings of the previous lecture on the Make utility. In this lecture, we are going to look at version control systems, which allow us to keep track of different files and folders which are actually created and changed over time in your project involving large practicals or large applications. So what is a versioning control system and why is it needed? Suppose you have your group of students, and these group of students are A, B, and C, and they are working on an assignment. Let's say this is the activity of the prior week, and everyone is trying to write a makefile to solve the activity. So let's say A wrote something which luckily worked, while B and C are still working really hard to get to the level which A has achieved. It will be useful at this time if somehow B and C can be informed that a working makefile is available with A. Fortunately, in this case, B is a roommate of A, and hence C immediately copies A's makefile and starts making it more useful. A is also trying the same. C is still trying to come up with the working makefile. A and B has edited their versions and found that none of them are working now. It will be useful if a copy of the working makefile is saved at this point in time so that what A and B had is not lost. A and B are debugging their versions while C has somehow written the best makefile possible. It will again be helpful if A and B can be somehow update their copies of their makefile to that of C's makefile. So you can see that when we develop software in a group, which is likely the case in the real world, as in this case demonstrated, there are times when you want to share your code with other people and you want to go back to your code, and also you want to go back to a prior version of your code, and if some other team member has made some progress, you want to incorporate those changes in your code. All these challenges are met using a versioning system, and we can realize all these different features using a versioning system. So generally, version control is a system that records the changes to a file or a set of file over time so that you can recall specific versions later. If you are a graphic or web designer, or if you want to keep every version of an image or layout, you would certainly want to. A version control system, which is also referred to as VCS, is a wise thing to do. Generally, a version control system, as already mentioned, allows us to revert files to a prior state, revert entire project back to a prior state, compare changes over time, see who last modified something that may have caused a problem, who introduced an issue, and when, and more. So using the version control system also generally means that if you screw up things later on, you can easily recover them or go back to a prior version. So one aspect of version control system is a local version control system, which can exist on your computer. So many people's version control method of choice is to copy files into another directory. And this is a acceptable method which allows us to actually keep the files or different versions of the file. One of the popular VCS tool is called the RCS, which is still distributed in many of the computers today. Popular Mac OS operating system includes an RCS command when you install the developer tools. So basically, the local computer has a directory in which you maintain different versions of the file, and the one which you check out is the latest version of the file, whereas the prior versions are stored in the computer itself. So basically, the RCS works by keeping patch sets, that is difference between the files. Say if version 1 and version 2, whatever the difference, this is called a patch, and this is of the diff, and that is kept in the version control system in a special disk on format on disk, and it can recreate any version of the file based upon those patches, how the file looked like at that point in time. the problem with this is, the good part is that this is a good system. It allows us to keep different versions of the file. But the bad part is that it is not global. It is only locally available to your machine. So it may not be useful if you're working on projects with other team members. So there was a concept of coming up with a central version control system, which is also popularly known as CVS. And this CVS was built into Linux operating system from very early on days. So the idea of the CVS is that you have now a centralized version control system where the files have different versions, and this is centralized and maintained. And on a computer, you can check out a certain version of the file. On a computer B, you can check out a certain version of the file, and you can check these versions back in. And if the same file was being modified by two people or two computers on two different computers, then if one checks in, the other will have to merge their changes before these changes can be checked into the system. So basically, this allows us to collaborate with developers on a set of files. Administrators have fine-grained control over who can do what privileges they want to give to different people. And the problem is that if the server, this particular centralized server, goes down for say some time or some hours, then during that hour nobody can collaborate at all or say version changes or anything they have worked on. So basically the problem is that this centralized version system is very critical, and if this goes down, then nobody will be able to do anything. So the idea of distributed version control systems came up, where the files are maintained, or copies of the project or files are maintained on all the computers, and Git is an example of the distributed version control system. So in this system, even if the server dies and these systems were collaborating via it, any of the client repositories can be copied back to the server to restore it. Every clone is really a full backup of all the data. There is redundancy. The files are kept on different computers, and this allows us to actually create distributed version control system. So generally the history of Git goes like this, that the Linux kernel was an open source software project of large scope. For most of the time, the Linux kernel maintenance between 1991 and 2000, changes to the software were passed around as patches or an archive file. But in 2002, Linux kernel began using a proprietary DVCS called BitKeeper. In 2005, the relation between the community that developed the Linux kernel and the commercial company that developed BitKeeper broke down. They had a fight, and the tool's free of charge status was revoked. This prompted Linux development community, particularly Linus Torvalds, who is the creator of Linux, to develop their own tool based on some of the lessons they had learned using BitKeeper. Some of the goals of the new system were speed, simple design, strong support for thousands of parallel branches, fully distributed, able to handle large projects like the Linux kernel. And this is how it led to CVS. So now most of the systems store information as a list of file based on changes, and generally there are different version control systems like CVS, Subversion, Perforce, Bazaar, and so on. And basically they keep a set of file of the changes to the file over time so as to be able to go back to a prior version of the file. So this is basically the centralized version system, CVS, concurrent versioning system, which is the traditional method where every file, every time you make changes, those changes are only the changes are stored, and then when you want to go back to a file, these changes are either added or subtracted from the file to lead to the snapshot at that particular point in time. In contrast, for Git, the version system stores the entire copy of the entire snapshot of the project, including all the 3 files, not just the changes. So yeah, it is burdensome in terms of the space it takes, but every version has the complete snapshot, so you are able to have more redundancy and recovery from a failure is possible. So basically every time you commit or save the state of your project in Git, it basically takes a snapshot of what your files look like, and at that moment and stores the reference to that snapshot. If your files have not changed, Git doesn't store the file again. Like for example, the file B, just a link to the prior identical file is already stored. Git thinks about its data more like a stream of snapshots. So whatever changes have happened, only then it creates a new snapshot. Otherwise, it keeps referring to the prior snapshot. So essentially, every operation in Git is local. Basically, local, you basically mostly need local files and resources to operate. And you don't need to connect to a centralized server to get resources, because there is a copy of the whole code available on your system. Git has integrity. Git uses this checksum method of SHA-1 hash mechanism, which is referred to as checksum. SHA hash have 40 character string composed of hexadecimal. So basically, it makes sure that the storage is complete and there is no part of a file or of a project missing. The other thing is, and it's also secure, because it's impossible to change the contents of any file or directory without Git knowing about it. And Git generally only adds data, so you can't change the file outside. So basically, idea is that the Git will keep track of your changes to the file as you work through, and you will have to use the Git system to be able to check in and check out or commit files, which we will look at as part of the future lecture. Git generally only add data when you do actions in Git. Nearly all of them only add data to the Git database. And remember that we need to be able to update Git about changes on the file. Otherwise, we'll not be able to keep track of the changes to the file. So now I'm going to show you one activity where you need to use the GitHub, which is a commercial deployment of the Git versioning system available on the internet. Remember, Git is free of cost. It is built into Linux or Unix or the Ubuntu distribution on Windows. But GitHub is actually a commercial company which is providing Git with features which people can use to share. And GitHub has become a very common source of sharing files on the internet. So in this activity, we have the same activity as the files in the activity 1 of the make. And here, just to separate the different groups of students, we have created a link like this, GitHub LAP, and the group _n. N can range from, if you are group 1, it will be _1, 2, 3, and so on. So the idea is to first create the repository. So you can create any repository with this particular structure on GitHub, and we have created this for you. The second step is to clone the repository. For that, you may need a username and password. And the third is that we need to download. So basically, when we clone a repository, the files in the repository get copied locally on your computer, and your computer has a link to the GitHub page. And then if you have some proxy settings on your in your university or office, then you may need to use the office config command to set up the proxy ones. And this basically gives you the configuration of the clone directory. So the steps are like this, that you go to the page, GitHub page, where you have github.com group 1, and in this you have a set of files, and then these are the files from activity 1. This is for group 1, and on your command prompt, which I have already shown you in the prior lecture, that you can install Ubuntu using the Microsoft Store, you can actually run git and see that it will be installed. But if you do not have a version of Git available, then you can basically install the Git using this command sudo apt-get install git, and it will install Git for you. So now, just to show you, I am in my home Varun folder, and if I ls, you can actually see that there are two activities, activity 1 and activity 2, and I can go into cd activity 2, and if I ls, you can see I have already done group 1. So what I had done, I have already run, so I have gone here, I have copied my git clone link, I have copied it, this one, and I have come here and I have run this type of command, which is git clone, and the same thing which I have copied here, right here. So I have put this is the path, and when I do it, I will get a local copy of my folder, ls, and if I ls group1, just for your curiosity, I will get all the files which are available here. So now I can do local changes, and then I can push those changes to the repository on the internet and also commit those changes. So this is my Git repository setup here. One more question which is asked in the activity is to actually set up the username and email, and you can actually set up a username and email to represent your identity on the Git as a user. And to do that, you will have to run two types of commands, which is config global with a global tag user.name Varun Dutt, and also if you want to run for the email, the command is git config global user.email varundutt.ac.in. This is my email address. So this is how you can set up your username and password, and we can also run the git config all command, and you can actually see that it gives me the option all. It has, oh sorry, not all, but it will be list. And you can actually see my username and email address are set up properly. So this ends this lecture. I would request you to try the activity, and we will meet in the next lecture looking at more features of the Git command. Thank you.